Hello everyone, this is Shubham Jha.
Vishal.
I'm Akshay.
I'm Sanjay.
Karthik Mohan.
So guys, today we are going to talk about LCD and its interfacing with 8051 microcontroller. A liquid crystal display or LCD draws its definition from its name itself. It is a combination of two states of matter, the solid and the liquid. LCD uses a liquid crystal to produce a visible image. Liquid crystal displays are super thin technology display screen that are generally used in laptop, computer screen, TVs, cell phones and portable video games. LCD's technologies allow displays to be much thinner when compared to cathode ray tube or CRT technology. Now let's discuss the key features of LCD. Low power consumption, voltage controlled, easy to read in bright light, declining cost, ability to display characters or graphics, intelligent controller and LCD display panels readily available. Now this is the circuit diagram for the interfacing LCD to 8051 microcontroller. Now 16x2 LCD module is a very common type of LCD module that is used in 8051 based embedded projects. It consists of 16 rows and 2 columns of 5x7 and 5x8 LCD dot matrices. The module we are talking about here is type number JHD162A, which is a very popular one. It is available in a 16-pin package with black light contrast adjustment function, and each dot matrix has 5x8 dot resolution. The pin numbers, their name and corresponding functions are shown in the table below. So these are the pins and their functions. So in this diagram, this VSS pin which we see over here is the pin which must be connected to the ground. The VCC one is the positive supply voltage pin. Normally we give 5 volt DCC over here. And the VEE or VE pin is contrast adjustment. RS is the register selection. R or W is read or write. E is the enable, and from DB0 to DB7 is the data pin. LED plus is black light and backlight LED plus, and LED minus is backlight LED minus. So pins which are available over here, and so we saw the functions in the diagram itself. Now this is the theory which we said in the starting of the pin diagram. Now let's see a video on which we will see how the LCD works.
Today's modern LCD technology is based on a discovery made by engineers Lehmann and Reinitzer around 120 years ago. Let's take a look at the technology in detail. In liquid crystals, the molecules are similar to long, drawn-out rods. As with crystalline structures, these molecules exhibit a strictly ordered crystal structure. The ordering of the molecules creates a directional orientation. In most LCD displays, the liquid crystals are embedded between two glass plates rotated by 90 degrees. This formation produces what is known as a twisted pneumatic LCD. A polarization filter is fitted onto each of the outer glass plates. These polarization filters mean that only one dispersion direction of multiple light waves emanating from a light source is allowed to pass through. The light follows the rotation of the molecules and, twisted by 90 degrees, hits the outer polarization filter. As the rotation means that the direction of the light matches that of the polarization filter, the light can also pass through this filter and brightens the outer glass plate at that point. If an electrical field is then generated between the glass plates, the special property of the liquid crystal molecule becomes fully apparent. As the molecules are dipolar, they react to the electrical field and are repelled. The rotated molecule structure is interrupted. When light then passes through the first polarization filter and follows the direction of the molecules, this hits the outer polarization filter and cannot pass through it. When a matrix is created from a number of these individual cells, it becomes possible to display graphics and images. To generate more colors, each pixel is divided into 3 subpixels. Color filters are placed over these subpixels in the colors of red, green, and blue. By triggering the subpixels differently, additive color mixing can be used to generate each color required.
Yeah, so now we just saw how the LCD works through that animation. So now we'll have a little bit more of how the interfacing of the 16:2 LCD module is done to the 8051. So the circuit diagram that's given here shows how to interface this 16:2 with the 8089S1 microcontroller. So the capacitor C3, the resistor R3 and the push button switch S1 forms the reset circuitry. Ceramic capacitors C1, C2 and crystal X1 is related to the clock circuitry, which produces the system clock frequency. P1.0 to P1.7 pins of the microcontroller are connected to the DB0 to DB7 pins of the module respectively, and it is through this route that the data goes through the LCD module. So then we have the P3.3, P3.4 and P3.5. These are connected to the read write and RS pins of the microcontroller, and through this route the control signals are transferred to the LCD module. The resistor R1 limits the current through the backlight LED, and so do the backlight intensity. POT R2 is used for adjusting the contrast of the display. Okay, so now we have a program that shows us the basic working of an LCD. But before that, there are 2 things we need to pay a little bit of attention to. The first one is LCD initialization. So there are 4 steps that need to be followed for initializing the LCD display. So first, we need to send 38H to the 8-bit data line for initialization. Then we need to send 0FH for making the LCD on, the cursor on and the cursor blinking on. Then we need to send 06H for incrementing cursor position, and then 01H for clearing the display and the return cursor. So now we have to now see what we have to do for sending data to the LCD. That is basically the LCD module has pins named RS, read write and enable. It is the logic state of these pins that make the module to determine whether a given data input is a command or a data to be displayed. So we basically need to make the read write, that is R bar W, low, and suppose the data byte is a command, then we need to make register selection, that is RS0, and suppose it's a data byte to be displayed, then we need to make RS1. So then we place the data byte on the data register, we pulse E from high to low, E is the enable, and we need to repeat these steps for sending another data. So basically what we are doing in this program is following these steps again and again. As we notice here, we have a couple of loops which we follow using the acall command. So we have disp and we have command. So suppose the data byte is a command, then we follow this particular loop, and suppose it's a data to be displayed, then we follow this particular loop. So let us just see basically what we are doing with the initial bits of data. Okay, so now let's see what happens. Suppose the command function is called. So then we move the value that is stored in the accumulator to port 1, and then we clear P3.5 and P3.4. So P3.4 and 3.5 are basically connected to the read write and the RS. So as mentioned earlier, RS has to be made 0, and we have to always keep the read write low. So now we set the value of 3.3, the P3.3 to 1. That is basically we are enabling it, and then we are clearing that, which is basically making that value also 0. So now we are calling a delay inside. Let's see what happens if the display function is called. So we have the value stored in the accumulator that is moved to P1. So then P3.5 is made high, that is the value of register selection is made 1 because we need to display the particular data. Then 3.4 is cleared, that is R bar W, the read or write is made 0. And then P3.3, that is enable, is made high. Then we clear the enable and call the delay as we did in the command function. So what happens now is we have different values different data bytes that are fed in, and suppose we need to show it as a command, then the command is called, else the display is called, and this is repeated for as many number of data bytes we have. So this is basically how the program runs. Thank you.